D.3, our third example of this part, volumes of chips. In this one, we will look at the production volume, mass production. So usually when chips are built, that number is really, really big. Yeah. So here, the cost is associated with the volumes. Yeah. So let's take a look. This question, quite different from what we have seen so far. Yeah. But it is an interesting question. Yeah. Example 5. There are two types of chips, type A and type B. Every time the volume of chip A is doubled, the cost per chip is reduced by 8%. Volume doubled, the larger the volume, the lower the cost. That's very natural, right? Yeah. So in the manufacturing industry, so that is very common. Yeah. But there is a close relationship between the volume and cost reduction. Yeah. Every time the volume of chip B is tripled, the cost per chip is reduced by 11.6%. Now we increase the volume for two chips the same number of times. Because one double, one triple, it is hard to compare, right? All right, so we can imagine same number of times. Both increase to, let's say 10 times, for example, right? 10 times. Then we can compare their cost or cost reduction. Right? Which one will have faster decreasing rate in the cost? Here we consider cost decreasing rate. Yeah. So this question, so you can see it is quite different from our transistor density increasing rate question. Yeah, quite different. Yeah. All right. So multiple choice, chip A, chip B. Yeah. But we need to do calculation to find the answer. Yeah. All right. The method we use is called a same volume comparison. So this one, we just learned previous example, same period, right? In the previous example, we consider same period comparison, right? And all these things in general, we call the same base comparison, right? Yeah. Initially, two things are given on different bases, but it is not convenient to compare. So we need to convert them to the same base. Then it's easy to compare. Yeah, the same idea here. All right, so here our base changes to volume. So chip A, chip B are given on different bases. Yeah. So the basic idea, we need to convert one chip to the same base of another chip. Okay, so the base here we choose volume as the base. Yeah. All right, so let's do the analysis. Chip A, let's look at the chip A. Yeah. Cost, volume. Yeah. Let's take a look. Yeah. What is the relationship between the cost and the volume? Okay, yeah, given. Yeah, so let's do it. When we double the volume, initial volume times 2. Yeah. You can imagine, so there is some initial volume, V0. Okay? Then multiply by this 2, the cost reduction is this. Multiply 1 times 8%. Then, so let's repeat this pattern. Yeah, so this is a pattern. Repeat this pattern again and again. Yeah. And we repeat how many times? A general n times. How about that? Then the reduction factor multiplier, yeah, also repeated n times. How about that? Yeah, the same pattern, right? Yeah. All right. Volume double n times 2 to the nth power volume. Okay, 2 to the nth. Yeah. Cost reduction also n times, then parenthesis 1 minus 8% to the nth power. Yeah. Right? Yeah. So this is the general relationship. Okay? General relationship here. Okay? Yeah. All right. Next, now we look at chip B. Chip B, we are given, we know the volume is 3. When the volume tripled 3, the reduction part 1 minus 11.6%. Okay, so chip A, chip B. How do we do the comparison here? Do comparison. Same volume comparison, right? Same volume. So the volume part, we want to make it the same. Here, a key step, critical step. If in your mind, you can imagine, you can pass this step, then you will get to the answer quickly. But this step may not be very easy. Sometimes, based on your intuition, may not be that easy. Here, we need to get to that step. All right, so this step is important. The n here, in our diagram, we repeat it n times. N is a positive integer, right? N should be a positive integer, yeah, in our diagram. But after we get the relationship between these two expressions, then we can change that integer to any positive real number. Not necessarily integer. 1/2, is it okay? 3.5, is it okay? So any positive, so this n, if we use any positive integer, this relationship is still true. This is the critical step. You need to understand. You need to understand. Okay? Yeah. Initially, it's integer, positive integer, but after that, we do extension. We extend from integer to all positive real numbers. So think about that. Is that okay with you? Right? Because this is a big understanding step. Big understanding step. Okay? Yeah. If you get through this step, then the remaining is straightforward. The remaining logic reasoning, pretty straightforward. All right. So let's look at the remaining part. Yeah. Now we can make both sides, chip A, chip B, the same volume, all three. Yeah. Because only when n, not necessary integer, positive integer, then we can get this, right? If you only use n positive integer, how can you get it? 2 to the nth equals 3. How can you get it? Right? You cannot. right? So that's the reason we need to extend it to any positive real number. Yeah, so we can make them equal, these two expressions equal. Okay, all right. Now, with that, we can use the same volume comparison. 2 to the n equals 3, same volume comparison. So let me run this whole same volume comparison. Yeah, set of equations. All right, chip A, yeah, so we just copy it from the previous page. Chip A, information, yeah. Chip B, there. Now we connect chip A and chip B. Yeah, all right. So using the same volume comparison. Okay, so chip A, we do the conversion, convert to 3x. Yeah, 3. So here you can see we intentionally make chip A, chip B the same volume. But when you do it, you need to establish, make these two expressions follow the same relationship, right? Same pattern, same relationship. You need to follow that. Okay? Yeah. How do we follow? Make 2 to the nth equals 3, right? Yeah, same volume same color volume assumption. Same volume setting. Same volume setting, right? Then also should be equal, right? Yep. Yep. Bottom the same, top also the same. Then we can compare with the chip B part, right? Yeah. X and this number, which one smaller, which one bigger? Then it's easy to compare. Here you can see, yeah, the idea now not that hard to understand. Yeah. All right, now the work. Yeah. Set of equation in this way. Okay, 2 to the n equals 3. Yeah. Parenthesis 1 minus 8% to the nth equals x. What is x? We can find the x value. Yeah. First, from the second equation, find the n value. Log base 2 of 3. So there is a number. We can get it. Okay? Then, from the first equation, we take log base 2, same log base. Yeah, same log base 2. So we get n times a log base 2 number. Yeah. But n equals log base 2 of 3. So you can see this number can be found. Yeah, so it is negative, approximately negative 0.19, negative 0.19. Yeah, so it's okay, negative number, it is okay, right? The reason it's negative is because this number is smaller than 1, so the second log is less than 0. So the first greater than 0, product, it's negative. Now it's okay. Yeah. Next, we calculate x. Log base 2 of x equals negative 0.19. Okay. Then x equals 2 to the negative 0.19. We can find a value using some, online calculator. So all these numbers, log things, I use the Wolfram Alpha. So the online Wolfram Alpha. All right, yeah. So I recommend this. Many of you know this. It's a pretty famous scientific computation, website. So they have a lot of powerful computation tools. Yeah. Yeah. Because some of the calculators cannot do the calculation like this, right? Some of the calculators very simple, on our cell phone, calculator app. Many times too simple, so we cannot do log exponent type calculation. Yeah. So then you just go to this website, do calculation. Yeah. All right. So here you can see we find x value. So approximately it's okay, good enough. Then we convert to the reduction format. Because both sides we compare the reduction rate. Yeah. That format. 1 minus 12.3%. So let us compare two reduction percent. Yeah. One is 11.6% reduction. Another is 12.3% reduction. Which one has bigger reduction, right? Yeah. So we look at from this way, which chip has bigger reduction over the same period of time? Oh, not same period, same volume, mass volume production, right? Same volume production. Obviously, chip A. With the calculation here, we get answer chip A in this way, reduction, its volume decreasing rate over the volume, right? Yeah. Number of times of volume, will be faster. Okay? Yeah. All right. Yeah, so that's this example. Yeah. So we finish our third example of this part. Yeah. Next, then we will discuss the main topic of this part, power and energy. Yeah. All right, so let me start here. Yeah.